So the next part of our lecturing is about high-loaded services. And what about we want to speak? First of all, we should understand what. Just a minute. Uh, in this block of the lectures, we will talk about high-loaded services. What does it mean? Big data management. Why big data is a create high-loaded high load for computational systems. Then infrastructure organization, containerized and virtualization, virtualization, and others. Maybe today we will talk just about first 2 or 3 ones. So what does hard-loaded service, what does it mean? First of all, when we talk about loading, it depends on the system who process it. For example, when we have a system which is ready to process one request, for this system, 10 requests, it will be high load for this system. Therefore, we should understand that high-loaded systems and theory of high-loaded system, it's about possibility to scale processing systems or computational system or environment where the request will be processed and process as many requests as we receive. So it's all about high-loaded system. As you see in this slide, just 12 years ago, we start talk about high-loaded systems, and these systems is not about number of requests. These systems is about availability to process as many requests as we need. Other example of the system. In one moment, we can have 10 requests. In 5 minutes, we have 100 requests. So systems should be ready to organize resources or computational resources to have some instruments for self-organization to process as many requests at the moment as it is required. So according to some definitions, number is not a point at all. High-load is a relative concept, so concept of not about number of requests. The resistance of internet projects to high-loads. Actually, one of the example according to resistance of these systems. For example, when you plan some applications, for example, some service, for example, you create some, I don't know, Telegram bot or some web service, and first you think that how fast number of subscribers will grow. Maybe one by one, but sometimes, and it's often, when all requests, no, all the number of subscribers growing up very fast. And in this case, you can lose your subscribers. Your system can lose subscribers because your environment, your infrastructure, computational infrastructure, is not ready to process lots of requests. And it's, I think you, mm, uh, if you don't have such examples in your life, maybe okay, but often when you open, for example, some governmental services, some other not services which at the beginning they work as mm, a system for less number of participants, then this system has problems with quality of service, which is so it according to these systems, what we so we have to plan the site architecture, how to organize resources, how to organize processing, business processing on this request. To all, because sometimes services need bases or some servers or some other technologies. So it's some complex and some complex of instruments, and these instruments should be organized in such way to process as many requests as you receive. Other definitions, for example, it's IT systems. It's the high load is when traditional approach to the work is of IT infrastructure is already not enough. Not enough for customer service. One server is not enough. When technique so or cannot cope the increased load, no, and so on. I talk about these examples when you need scale infrastructure urgently. All this about big data. And for sure, we should we will see some examples maybe later. One of the example of high load system, for example, Facebook. Everybody, or not everybody, lots of millions of people use this service. It's a web service, and you have to how it should be organized infrastructure of these services to process so many requests for no, of subscribers to this system. It's one of the requests, maybe of the examples. For sure, we have lots of such examples. The main challenges of or main problems with high loading is are the main challenges are volume of data, um, thousands of or millions of photos, millions of videos, and so on, so on, so on. So huge volume of data. Complexity. Also, as usual, we talk not about one kind of service or one kind of requests, different requests to different sub-services, and it's very complex tasks for the infrastructure. Rate of change, for sure, because, for example, somebody sent, I think you understand this, because somebody, I don't know, always something happens. And when something happens, people goes to Facebook or some look through the some elements. So we don't have um, average number of requests in the during the period of time. We always have different situations or rate of change of the situation of the system is very high. From other side, the overall high-load architecture of the large application should be designed with both of terms. From one side, we have to, software components should be ready to process. From other side, we have to have enough hardware to operate the requests. So it's complex task to provide service for high-loaded system. When we talk about high-loaded, we have to understand six main ideas or six main principles. Why we need it's for different. Why we need to provide all these principles? First of all, because you have to provide high quality to each subscriber, each user of your system. And therefore, if one user will not receive expected quality of service, next time you lose this subscriber. Maybe not at the next moment, but it's it's very important. All each request of from that million of that requests is very important. Therefore, we have to provide availability. So system should be ready to process all requests. The system should be should have high performance. Why? Because we need, for example, actually performance is one of the main key moment of all no, of each system who provides services or who works and why it works, because you always have to receive more than you pay, and there it's different performances. How effectively works your system, how the productivity of the system is it's very important. So why it's so important in high loaded system? For example, because the system should be should pay. You can always, no, for example, for process 1,000 requests, you can uh, pay all time for this 1,000, no, for resources to process 1,000 requests. But very often, 1,000 requests, it's number in, for example, in 9 o'clock. Once a day, you have 10, 1,000. Last other moments, you have just 10 requests. And therefore, you have organized your infrastructure to no, you have to organize see this system with high performance. So performance should be more than no, as big as you can give it. According to scalability, it's also the connected questions, because we have to scale the system quite often. You can because you remember we talk about fast changes, high rate of the changes. So this high rate of the changes have to um, this high rate of the changes initiate changes of infrastructure or changes of the system who provides this high loaded system. Therefore, we have to have scalability on this. Yes, the reliability, it's about so, гнучкість, да, українською. Um, System should react on changes, and this calls reliability. So, as often system is changed, or subscribers is changed, or number of subscribers is changed, system should uh, be reorganized to provide processor everybody. Manageability, for sure, when we will look through the example today, and when we what does mean manageability? It means that we have to control all processes on this system, and for sure, when you have huge number of requests, you have thousands or millions of the subscribers who create these requests, and maybe you need more than one server or this infrastructure of your this infrastructure is not so clear, so not so easy to understand. So all processes should be managed. You should manage all processes. Manage flows of requests, manage issues who process this request, manage, I mean, software application, manage hardware or infrastructure. All this should be managed to to have good performance, at least. No, and for sure you have cost because you have to receive more money than you spend. For example, it's always when we talk about efficiency, we talk about how many we spend and how many we received, and this difference is very important. So it's our прибуток. So something like this. Okay. According to examples of high-loaded systems, I think you, as I told, and you see in the slide, it can be Google, Facebook, Flix, Amazon, YouTube. So actually, each huge system, online huge system, it's high-loaded system, because if this system works on all over the world, for sure it has have to process lots of requests. Browser-based multiplayer games, CRM, customer relationship management. Actually, we will look through the CRM system for computer game. So what how this system is organized, how to process lots of requests at the same time. Mainly it's different micro services who provides its small tasks. As we see here, you see Um, mm, some services, each service has its REST API, with which some other service connect and communicate with this service. Um, so and each of the service ready to process some number of requests, and how it should work, we will see. We uh, some words about my microservice architecture. What is the difference of monolith architecture and microservice architecture? Uh, Main principle is that each microservice can be packed on some container and works as independent issue. And this independent work uh, make it more flexible, more moving. You can move the this microservice from one machine to another, from one cloud to another cloud, and maybe sometimes all its these modules can be can be in different can place to in different resources, in different services. In monolith architecture, you have to place all modules on the one application service, and when the number of requests will growing up, we can have problem with resources, because each module number of resources for each module, it's uh, growing up independent, and in general you can so limits of the resources can play bad joke with you. So it's very important to make it flexible, to make it ready for processing a huge number of requests. Microservice architecture allows us. Also, we can provide not only one module, we can provide the same elements. For example, some function. It can be, you can uh, mm, clone these modules, and lots of modules can solve the same problems, and these modules can be placed in different uh, physical hardware. And for sure, this idea of this division of the services of these modules, its idea for sure is used for different, for example, such websites. Because, for example, if mm, just imagine it, if Google will use monolith architecture, what we will receive? We will receive that how huge should be that computer or that server where all Google services in one will be provided. I think it's very hard to to even imagine it, because number of requests, number of subscribers who ask that who ask that services, it's very huge, and it's you should, as we talked in previous lectures, I explain you how it in general works. For example, when we have some is the NFV, for example, service, yes, so some function in of no, some network function, and we should understand that this network function, the no service, it's connected with um, connected with real hardware, and that hardware should be ready to process it. And therefore, we have orchestrator here to manage who, where should be placed, how to organize this communication, and so on, and so on. So it's this um, technology, microservice technology, or this architecture should be used for the mm, for high-load services. And maybe more detailed, we look through the CRM system. Also, what does that mean CRM? CRM is system who support subscribers or who support some business processes for collect and process information about subscribers. So main tasks of or main points of CRM system is target. It means that propose to somebody exactly what he need. But it's maybe the last one. First, we should monitor our system. So it's CRM system. It's about collecting information about the system. From other side, payment. So you should check and propose the services. So you should check that each subscriber who receive the service pay for this for it. From other side, marketing, so propose something based on no, make a good proposition for people for subscribers. This you understand what does mean. Also, it's about customer support, where customer support where uh, you have you can answer to the people, you can say something, and so on, so on. So customer support. Also, it's some cloud solution. Why we need cloud solution? Because we use cloud solution for processing, for make that ideas for processing all that tasks for no processing system. Cloud is where this CRM system works or placed. No, and Targent, it's about uh, analyze different information about subscribers' behavior and propose exactly what that subscriber need. Its main points of CRM, what does mean CRM? CRM strategy is to create a single ecosystem for attracting new and developing existing customers. So why these CRM systems it's so important? It's not so important. It's just one of the example, but I think you will be surprised when you will hear about next uh, example. Next example is a CRM system for online game. A CRM system for online game. What does it mean? How it used? Um, what and what sub elements it has. I'm n- rem- uh, for so for example, we have online game and with million or more subscribers. This game uh, for for make money on this game, the developers or company of which who developed this game, they uh, connect a CRM system for this game. Uh, what should what is the main task for this CRM system? First of all, it should collect data about subscribers. What does it mean? It means that, for example, it's a game with map and so on. So it's quite a huge game, strategy game. So how do you think? How many information they collect? It's a question to you. How do you think? How many collection collect this CRM system for online games? What kind of information they collect?
It depends.
For example, for processing, for providing the main service, no, not main source, for providing to receive maximum money from this game, from their subscribers. Uh, Interesting that they collect all information, for example, where this player goes, what he saw, what he do when he saw something, for example, I don't know, some kind of weapon, some kind of some kind, no, as you know, in these games, they make money on weapon sale. So some features for players. They sell some features for players, and therefore uh, uh, they have to guide what they do, what they interested in, what kind of weapon they look through, for example, and so on. And when you talk about 1 million people who plays during, I think this, um, when you where you go and what you do, it's fixed twice, for example, for twice a minute or something like this, and players play during hours or 1 hour or that it depends on the subscriber, and this system have to collect and process all information about about the subscriber, about million of subscribers. Therefore, they need some instruments. They need some um, features uh, mm, mm, for processing all that information. And first block of this CRM system is storage of the data, and they use Apache Storm for processing um, processing uh, all online activities, for processing как события, each element of that game. From other side, they have to process this information. Therefore, they use Kafka, because Kafka, also Apache Kafka, because Kafka it's about queries processing. So it's kind of querying uh, query information, storage information in queries, and receive information from that stored as a queue, that information. And also they use Hadoop, Apache Hadoop, because it's it's something like all information which was cached is sent to Hadoop. So to maybe to process this in the future. But anyway, so to say to for not to lose any information, they use Hadoop. Then um, then after catching information, storage of the information, processing that information, this CRM system has consumer, so something like analyzer of the information, some queues. So what no, you see this in the picture. What is the main idea? The main idea is to catch state of the subscribers, understand what these subscribers maybe did in previous times, and use for apply for him some ideas. For example, you can propose each of them. For example, on Wednesday, you propose half price for this kind of weapon or that kind of weapon. Or so it's maybe so this the templates for no this proposition for the that can be in general from one side. From other side, it can be exactly for that user. For example, you go to look through the weapon. In 3 minutes, you receive proposition to buy this weapon in half price. With half price. It's exactly because they have good system of analyzers and propose you what you wish with half price. Um, in this picture, it means that all states sent to the data API. To this data API is provided some some people or some actors who propose different this or that uh, exactly proposition. From other sides, for example, no, as I said, today we give something or we buy something with half price and so on. Template database, it's about so different templates. For example, when you go here, you can receive this and so on. So it's just templates which is used for which is used for processing the requests. And uh, for so we how we should organize or we should um, so this is for processing the exactly proposition. From other side, this producer of this proposition is use some other information from this Kafka storage. So this consumer who understand more clearly the behavior of the customer and this information also is used for producer, because, for example, if you no, it's connected also with delays. For example, when you receive information, and so you want to apply some template, but in the same time, the subscriber is have not possibility. For example, he died for this in this game, and so on. Therefore, all of these elements of CRM system, all of these elements, it's you should understand that each block has really high load. So we have to plan the resources. We have to organize the resources for uh, mm, for processing no all requests, what all tasks which is created with this system. Also, according to storage, you can see that here is different databases. These databases is not really senior. It's NoSQL databases because they need they have to work with very huge number of requests, very huge. So therefore, we can't use the common solution for high-loaded system, and therefore we look through them here. Do you have question according to CRM? What does it mean and how it works and so on, so on?
No, it's fine.
Okay. Then we talk about big data management. Actually, it's about some here it's open source databases, and why I talk here about this, because I want you to understand that all no that each system who works with high load, he works with also with databases, so he works also with data because we have to collect, process, and so on this data for receive the good solution. According to what kind of events or something like this should we do? First, it's we need to fix event. We have to catch the event. This can be used Apache Storm, Apache Kafka streams, Spark streaming, Apache Flink, Samza. So it's different open source technologies which is used for catching or fixing the event. For handling event, Apache Kafka is used. What is the difference between catching and handling? To after you catch the information, you have to впорядкувати, to organize the order of the data, and when you organize the order of the data, you can process the element. No, process the requests, each request by request. Therefore, you can use Apache Calc. Main principles of this I will show you. Also save event information is just for saving everything without any sorting, ordering, without any things. It's Apache Hadoop used for collecting all data from the CRM. Common features are distributed data schemes and framework. What you can see here? You can see, first of all, it's application purpose. All of the framework are designed specifically for processing big data streams and processing big data streams on fly in real time. From other side, its main application purpose. Relevance, it's about that each of the nodes environments is widely used for in practice among the large IT projects and the level of in different level, the level of, for example, Facebook, Google, and so on. Also, big data systems of public, various business case for of public and private companies. So it means that all as all information that should be independent. Cluster architecture is used for organizing infrastructure, for organizing environment where it will physical environment where it will be works. Also tasks of parallelization. So we have to divide the same task into parallel groups for processing to raise the speed of this processing. Also should be full tolerance. It means that we should guarantee that all information, all requests, all sub requests will be processed in any for sure. So even if we receive, if we have problem with something, we know that in other replication of this task will work correctly. And there you can see for different kind of frameworks how it works and what criteria is always. First of all, data approach. It's for example, Kafka streams and streaming only. Storm is streaming and benching with Tident API. Some are also streaming, Flink streaming and bench. So we can see here different criteria and how it works. For main criteria is data processing approaches, latency, how it works, SIEM primitive, how to divide this unlimited information for different blocks for managing. For example, Storm has tuple, a stream of data in form of so it means that all data is taken by some tuple to for processing each tuple by tuple. So block by block. So this tuple is block. Also, for computational primitive, what kind of what number of resources is processed. Then message deliveries, semantic, so exactly once, at least once, and so on. Just then we can talk about some saving application, stateful data sources. And why I talk about this? Because I want you to understand that this big data from one side, this big data system for big data, they have from one side they have differences. These differences works. These differences no, they works on different for solving the different tasks from one side. From other side, even if they solve different tasks, they can, for example, organized by supported different languages. So, and you can choose that system who allows you more than others. But it's usually actually when you come to some company, you receive some existing system, and this existing system after you should work and process and find better solution and so on, but you work with that system what you have. Anyway, it's about querying we will talk about maybe next time. Today I just want to explain you that big data, high low, it's not something not about us. It's always in any processes, in any very spread used services, and for creating, for understanding what we should do with that services, we have we will look at that system from different points of views, and then we can organize the infrastructure, organize the orchestrator for better solution, for better solution. Okay, I think it's quite enough for today. Now I will send you the link for our test, and I think during the week you can complete it, and everything will be good. Do you have a question to me?
Well,
No.
it's not a
Oh,
question, but it probably will be interesting. It's not now, maybe on the next lecture, to hear like different examples where when some of the framework will be like the best solution. I mean, like they're, as you said, they have some like difference, yeah, and
yes,
they're like
we will talk about storm. We will look through the one of the examples. So we will you see, we will talk about Apache Storm, Apache Kafka, Apache Hadoop, and main principles how it works how they works. And also some links connected where you can read this or that information. Okay, okay. Thank you for I understand your proposition. I hope next time I will explain you more detailed.
Yeah,
Okay.
yes, thank you.
Thank you. Thank you very much. You can I will send test to the group. See you. Goodbye.
Yes, thank you. Bye.
Bye bye.
And till the next week we can do a test.
Yeah, during the week you can do
Okay.
this.